Hey guys, welcome back to Click Academics. In today's video, I'm going to solve the equation square root of 15x plus 2 root 15x minus 41 is equal to 7. So I know at first glance this might look like a weird equation, so let's just go ahead and solve for x. So what I'm going to do is first let the variable t equal to the square root of 15x minus 41. So this is just so that we can, simplify this a little bit, make it a little less complicated. So this means that t squared is equal to 15x minus 41 because the square root of something squared is just 15x, is just what's inside the square root. So that means by rearranging this, t squared plus 41 is equal to 15x. So now going back, I have t squared plus 41 plus 2t is equal to 7. Because t squared plus 41 is 15x, so we have 15x over here, and I have this plus 2t, t being the square root of 15x minus 41. So I'm just rewriting this in terms of t. Now I'm going to square both sides, so I have the square root of t squared plus 41 plus 2t squared is equal to 7 squared. So now I have t squared plus 41 plus 2t is equal to 49. And if I subtract 49 on both sides, I get t squared plus 2t minus 8 is equal to 0. Now from here, what we have is a quadratic equation. And to solve this, I'm going to use the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. And in this case, a is 1, b is 2, and c is negative 8. So I get t is equal to negative 2 plus or minus the square root of 2 squared minus 4 times 1 times negative 8 all over 2a, so 2 times 1. And this is equal to negative 2 plus or minus the square root of 4 plus 32 over 2, which is equal to negative 2 plus or minus the square root of 36 over 2. Now from here, I have two values of t. I have t is equal to negative 2 plus the square root of 36 over 2. So this is t of 1. And I have t is equal to negative 2 minus the square root of 36 over 2. So the square root of 36 is 6. So now I have t is equal to negative 2 plus 6 over 2. And t is equal to negative 2 minus 6 over 2. So this means that t is equal to 4 over 2, which is equal to 2. And t is also equal to negative 8 over 2, which is equal to negative 4. So I have t is equal to 2, and t is equal to negative 4. So from here, what I'm going to do is, again, I have two cases. One case where t is equal to 2 and one case where t is equal to negative 4. So for case 1, I'm going to use t is equal to negative 4. So when t equals negative 4, recall that t squared plus 41 is equal to 15x. Meaning, I have negative 4 squared plus 41 is equal to 15x. And this means that 16 plus 41 is equal to 15x. So now from here, 16 plus 41 is 57. So I have 57 is equal to 15x, and I'm just going to rearrange this as 15x is equal to 57, just to make this a little more simpler, having x on the left-hand side. And now I'm going to divide both sides by 15 because we want to isolate x. So I get x is equal to 57 over 15, which is equal to 19 over 5. So x is equal to 19 over 5. This is going to be one solution. Now for case 2, we have t is equal to 2. And again, recall that t squared plus 41 is equal to 15x. So now I have 2 squared plus 41 is equal to 15x, meaning 4 plus 41 is equal to 15x, and 45 is equal to 15x. So now by rearranging this, I have 15x is equal to 45, and if I divide both sides by 15, I get x is equal to 3. So I have two solutions of x. However, we have to check them because it's likely that one of them won't actually work out. So to check, I have the square root of 15x plus 2 times the square root of 15x minus 41 is equal to 7. Let's first check 3. So for 3, I have 45 plus 2 times the square root of 4 is equal to 7, meaning I have the square root of 45 plus 2 times 2 is equal to 7. So the square root of 45 plus 4 is equal to 7, meaning the square root of 49 is equal to 7, and I get 7 equals 7. So this solution is right. However, we have 19 over 5 still. So I have the square root of 15x. So 15 times 19 over 5. These two cancel out to get 3. So 3 times 19 is going to be 57. So I have 57 plus 2 times the square root of, again, 57 minus 41 is equal to 7. This turns into 57 plus 2 times the square root of 16, which is 4. So I get the square root of 57 plus 8, which is the square root of 65. And this does not equal 7. So that solution is rejected, and my only solution is x equals 3.